In this video, I'm not going to do any calculations. It's all going to be about how you state the transformations involved. Here are two examples, and both of these examples might look similar to you, but their transformations will be different. First, let's write down the base function that we think this looks like the most. Again, if you think about some of the most common base functions, you think about y equals x cubed, you think about y equals x squared, absolute value of x, root x, these sort of parent functions, 1 over x. These two equations both appear to look the most like y equals x cubed. There's nothing squared, there's no square root, there's no 1 over x involved. So the base function is y equals x cubed. And in the first example, you see that both the 2 and the 5 appear to be outside of the function. They're not involved in the bracket. When you have transformations that are outside the function, they will be vertical transformations. They're going to be affecting the y values of the function. And when you have transformations that are inside of the function, like in part B, all of this is inside the function. These will be affecting the graph horizontally. So there are going to be horizontal transformations that will be impacting the variable x. So the first one, it appears as if we are multiplying the y equals x cubed function by 2. So your y values will all get doubled. And that's how we're going to say it, that it's a vertical stretch by a factor of 2. And then we have a plus 5 at the end. When you add 5 to a y value, you're increasing it by 5. So we're going to call that a vertical translation, and it's going to be up 5 units. So here's how we state the transformations for part A. A vertical stretch by a factor of 2, so we read them left to right, and then it's followed by a vertical translation up 5 units. That's what happens when you have transformations that are outside of the function. And as you can tell, they're very intuitive. You multiply something by 2, you're stretching it by a factor of 2. You add 5 to them, you're moving them up 5 units. All of this makes sense. For part B, though, everything that's inside of the function, that's going to be impacting the variable x. These will be counterintuitive. You can think of it as it's going to be the opposite of what you think is intuitive. Let's see what I mean by that. If you look at the 2 right there, instead of multiplying the x values by 2, think of it as 2 over 1. Flip it. When you flip it, you get 1/2. So the x values are actually going to get multiplied by 1/2, and we call that a horizontal compression. Compression because the numbers get smaller, and they're going to get smaller by a factor of 1/2. Also, if you add 5 to an x, right, naturally you think x is increasing, so on the x-axis, you're moving towards the right side. But again, if you remember that with x, with the horizontal transformations, it's the opposite. We're actually going to be shifting the x values 5 units to the left. So a plus inside of the function, adding 5 to x signals that you're moving the points 5 units to the left instead of 5 units to the right. Lots more examples to come. The next two examples both appear to use the y equals root x function. So right away, I can say y equals root x is the base function from which these are obtained. Looking at question C, just like question A, it appears as though the 1/3 and the -1 are occurring outside of the function. Both transformations appear to be outside of the square root. And that means that they're going to be vertical transformations. They are going to be affecting the y values. You need to be able to see it that way. Question D, though, if you look at question D, it appears as though all of these transformations, the 1/3 and the -1, appear to be done inside of the square root. And because they're done inside of the function, that means that they're going to be horizontal transformations, which are going to impact x, and they're going to be counterintuitive. They're not going to be as easy to think about as those in question D. So look at the difference in how we write them out. In question C, we're going to say that there is a vertical compression by a factor of 1/3. That makes sense. If you multiply y values of the root function by 1/3, you're making them a third as big, so you're shrinking them. We call that the compression by a factor of 1/3. Then later, you are moving the y values down 1. Every time you subtract 1 from a y value, you're moving it down, so we say a vertical translation down 1 unit. But when we look at question D, it's not going to be like that horizontally. So here's what we say. It's actually going to be a horizontal stretch by a factor of 3. Remember that we take the 1/3 that is multiplied by x and we flip it to do the opposite. When you flip 1/3, you get 3/1. But if you're multiplying a value x by 3, you're making it bigger. So it wouldn't make sense for me to call it a horizontal compression. No, we are stretching. We are multiplying the x values by 3. So think of this as multiplying the x by 3. And yes, that is what's going to happen if you were to do the actual graph. You wouldn't be multiplying x by 1/3. Next, like I said, it's counterintuitive. So when you look at x minus 1, if you go on the x-axis, normally when we subtract 1, we're supposed to be moving a number to the left, but it's the opposite. It's counterintuitive. We're actually going to be moving the x to the right one. We're going to be adding 1 to the x values, so we call that a horizontal translation to the right 1 unit. It's best to memorize that with the horizontal transformations, it's always the opposite of what you think is right. Okay, let's now move on to some more examples. These two. You can look at them quickly and think about the base functions you've seen. Right, these were the base functions we had seen. Think about which of these it looks like the most. Should be intuitive by now, right? There's no square, there's no cube, there's no root, but there is an absolute value. So the base function is y equals absolute value of x. Transformations. These two questions involve something new I haven't addressed, and now it's time to address it. There's a negative there. This negative, whether it's inside or outside of the function, is going to be a reflection. So negative means a reflection, and we got to think about how they are reflected. The first one, the negative is outside of the absolute value, while the second one, the negative is inside of the absolute value. So having a negative outside the function, well, that's telling you that the y values are going to get flipped. So if you have a y value that's, let's say, a 7, it's going to become a -7. If you have a y value that's a -2, it's going to become a +2, and so on and so forth. So we call that a reflection. There is a reflection over the x-axis. Reflection over the x-axis, that means that the y values are going to flip. Positives turns negative, negatives turn positive. Remember it that way. And then if I want to address the compression or stretch factor, I just look at the 4. I ignore the minus. I just think of the 4 on its own, and I think, is the 4 greater than 1 or is it less than 1? Since 4 as a number is greater than 1, we're going to say that this is a vertical stretch. Don't get confused or distracted by that negative. That negative has already been addressed as a reflection. But 4 on its own is greater than 1. That's why we're going to call it a vertical stretch by a factor of 4. Next, I see a plus 2 added to the y values. So plus 2 outside of the absolute value added at the very end of the equation is going to move up all of your y values 2 units. Vertical translation up 2 units. Look at question F. Everything I said, the negative, the 4, and the plus 2, they're all happening again, but this time it's inside of the absolute value. So all of these are going to be horizontal transformations. They're going to be affecting x. The first one is the negative. Putting a negative on the x will flip the signs, and we call that a reflection over the y-axis. You flip your x values, positives turn to negative, negatives turn to positive. All of that is called a reflection over the y-axis. Next, we have a 4 again. 4 is greater than 1. But remember that horizontally, we do the opposite. Horizontal transformations, we always think of them in an opposite sense. So if you take a 4 and then you flip it, you flip a 4, it becomes 1 over 4. And now it wouldn't make sense for me to call this a horizontal stretch. So it's going to be the opposite. Instead of multiplying the x values by 4, we're actually going to be multiplying them by 1 over 4, which is going to make them smaller. So we call that a horizontal compression by a factor of a quarter. Then I have a plus 2 inside of the function. So if you were to add 2 to an x, you would be shifting it 2 units to the right. But remember, we do the opposite. We actually subtract 2. So it's going to be a horizontal translation to the left. So when you have x plus something, that's going to mean going to the left. When you have x minus something, that's going to mean going to the right, because it's the opposite of what we see. That's how the transformations actually impact the graph. 2 more examples. Let's do one with the 1 over x base function. If at any point you need to review these again, you might need to, especially if you're weak at transformations, you might need to review this video several times, maybe take notes, review it again, and come back so that it makes more sense to you. G and H. Both of them have an x at the bottom, so our base or parent function is the y equals 1 over x function. Let's look at the first one. I have a negative right after the equal sign, so we know that this negative is going to flip the y values. We're going to call that a reflection over the x-axis. That's how you flip the y values. But that 6 is a little bit on the confusing side because it's not written right over here. If it had been written over here, it would be easy for me to tell you it's a vertical stretch. But the good thing is we can actually rewrite it like that. So I'm going to take that 6 and move it out in front as 6 over 1. You can see that this result will be the same as before. 6 over 1 times 1 over x. When you multiply these together, you multiply 6 and 1, 1 and x, and you get 6 over x. So I haven't changed anything. I just thought of writing 6 over x as 6 over 1 times 1 over x. And now I can see the 6 right there. 6 as a number is greater than 1. So we're going to have a vertical stretch. Vertically, what you see is what you get. It's intuitive. If the equation says you're multiplying your base function by a 6, then you know you're going to be stretching the y values by that factor. So this is going to be a vertical stretch by a factor of 6. And later on, you add an 8 to all of the y values, so you're going to be shifting the graph up 8 units. And that's how we write them out. Reflection over the x-axis. That's for that negative sign we see right there. A vertical stretch by a factor of 6, because it's intuitive. When you multiply a function by 6, you're making the y values bigger. and then a vertical translation up 8 units. Again, because it's intuitive, you're adding 8 to all of your y values. And then in h, you have to forget everything I just told you and do the opposite. The negative, there's this negative though is now inside of the function. You see all of these in the denominator of 1 over x, it's considered inside the function. The transformations are not happening on the outside. It's not like part A where you had the 6 at the front and an 8 at the very end. These are all inside of the function. It's inside of the fraction in the denominator. It's all going to be affecting x. So these are horizontal transformations which will affect x, and they're going to be the opposite of what's intuitive, just like before. The reflection part, reflection over the y-axis, this is to deal with the negative, and it's the way to flip the values, the sign of the values of x. Those that are negative become positive, and positives become negative. Remember, I said it's going to be counterintuitive. So we see 6, which is like a 6 over 1. If you take a 6 over 1 and you flip it, it flips over to a 1 over 6. So you're going to be multiplying the x values by 1 over 6. And that means that they're going to get smaller and smaller and smaller and smaller, much smaller. A horizontal compression. They get smaller. They get multiplied by 1/6. They shrink. And then we have the plus 8, which remember, a plus means you're actually going to the left. So that's why I'm going to say a horizontal translation to the left 8 units. I hope this makes sense. I know it's a lot of information, but hopefully you can replay it as many times as you need to get better at it.